We're going to spend the rest of the time just looking at the normal distribution. If you recall, the normal distribution is this symmetric. Some people call it a bell-shaped curve, but formally it's called a normal distribution. And we want to kind of notice standard deviation. If you recall, standard deviation is the spread or the variation. We want to know how spread out this is. So it's just a measure of a spread. I always think of it kind of as a meter stick. It's some sort of meter stick that I'm measuring. If I'm really spread out, what happens to my curve then? It's really elongated. So this has a higher, if we call standard deviation, we'll call SD, and this has a low standard deviation. So we kind of look at the spread and where they're at. How do I know one's higher? We'll look at the spread, and if this was on a number line, those tails are far away from the center, which is both the median and the mean. So let's look at this in terms of percentages, and you might want to say, why would a teacher even need to know this? Well, if you think about grades, sometimes people say, oh, let's grade on a bell-shaped curve. Let's curve it. Well, I'll show you what happens when you curve something. But more importantly, when you get testing back, it's typically norm reference test, meaning that we're going to have test scores that fall in here. The test was built so that you would have this sort of a display. And here's the center. Oh, we better make that clearer here. Here's the center. And if you recall, we're going to call that the mean. We're going to label it X bar, or you could label it the median. So if I take one standard deviation, if I go up one standard deviation, we'll use sigma, I could have used S, or down one standard deviation in this range, we will have, and it should be again symmetric, we will have 68% of the people falling in that standard deviation. So we're looking at these in terms of categories where people are. What we also need to know is that if I landed right here in the center, if that was my test score, that would show that 50% of the people are above me in their score and 50% scored below me. So we're going to kind of look at this curve in what we call these percentages, because that's where they get them. If they say you scored in the 89th percentile, that's where they're finding them. So we went one step. Let's take another step here, and let's call it plus 2 standard deviations, and we'll take a step down, and notice they should be symmetric, minus 2 standard deviations, and that's a sigma there. And so how much data falls within that region? Well, theoretically, we have found that in this entire region, 95% fall in this yellow region. So I'll color it in yellow here so we can see in this region, almost all of us fall within that region. So we'll be practicing some of this in class too, but that would be our 95. So right now, one step above is 68. If I go, I should say one step above and below, 68% fall. Two steps above and below, 95%. And typically we'll go out to 3 steps above and below. So plus 3, and down here would be minus 3. And in this region, 90, what we call is the 99.7 rule, 99.7%. So it's the 68, 95, 99.7. So that means that almost all of us, as a percentage, fall within this whole curve. Now notice I didn't close my curve off. There's open ends and they don't fall down to that baseline. And we do that because if you think about height, I'm 5'6", so I'm exactly right in the center for females in my age group. I'm right here. Well, there's actually a female that lives in China that's over 8 feet tall. She is way out here. So how many steps above is she? Oh, probably 7 steps. And that's what we're going to be working to find is how many steps are you? But what happens is with these percentages is we need to kind of look at, we know this is 50, we've got to know these values. So if I'm exactly 1 step above, what is my score? So we're going to look at this 68 as 34 in this section of the 68 and 34 in the second section of the 68 because it's symmetric and divide it in half. If I was at 50 in the top and the next person exactly 1 step above me would be in the 84th percentile. Now, how did I get that? Well, I knew this was 50, and I went 30 more, so 84th percentile. If they were one step below me, if they were one standard deviation below me, they would be 50 minus 34, or they would be in the, check this out, 50 minus 34, they would be in the 16th percentile. So if you're thinking of grades, this grade level right here would be your C, and it would have the bottom 16% up to the top 16% would not be in that group. So now if we want to take it the next step, what if I was 2 steps above or 2 steps below? Where would I be at? Well, because everything is symmetric, I can say, well, I know that area is 95%. And if I take off the 68%, I end up with, if you go ahead and subtract this, I end up with 27%. And so what am I going to do with that 27%? Well, I have to notice that I have 2 regions that make up that 27%. So I'm going to take that 27 divided into those 2 regions because it's symmetric, and I get 13 and a half. So this space right here is 13 and a half, and this space is 13 and a half. So if I step up one more standard deviation, I'm at the 97 and a half percentile if I score 2 standard deviations above. If I'm at 16 and I go down 13.5%, I'm at the 2.5% level. So if you get maybe you got a test home when you were younger and it said that you were in the 97th percentile, you can see on the curve that you scored in this area, which is quite a ways above everyone else. That means that 97.5% scored below you. 97.5% scored below you. So if you are in this region, this little space is 2.5 because we just round this to 100%, and this little region here is 2.5. So we call that 0. We don't really forget about that there are other people out there that may have scored much higher than you or are much taller than you. So we leave that gap there. So this is what the percentages are based on. And we use this curve so that we can compare and look at things that are allowing us to generalize and tell about the whole population. So that's our next problem sets to do.